Hey everyone, my name is Derek Bransford and I'm a senior curriculum developer here at MuleSoft. I work on our training and portfolio team. Today we're going to be introducing you to some common Salesforce integration patterns utilizing MuleSoft. We're going to talk about the most common patterns that we see in integrations and talk about the components that exist within MuleSoft and Salesforce that will help you achieve those patterns. Then we'll talk about some of the security aspects around those and talk about the different ways that you can implement these patterns. There are some that are recommended or best practices, and then there are some that may be still good, or there may be some that are suboptimal. So we're going to really break those down and get into it. All right, let's do it. The first pattern that we're going to look at is called request and reply. In this pattern, let's say that you're using Salesforce to track leads, manage your pipeline, create opportunities, and capture order details that convert leads to customers. But the Salesforce system doesn't contain or process orders. After the order details are captured in Salesforce, the order is created in the remote system, which manages the order to conclusion. When you implement this pattern, Salesforce calls MuleSoft via the API kit, as you can see in the diagram, to create the order and then awaits for successful completion. If successful, the remote system synchronously replies with the order status and order number. As part of all of the same transactions, Salesforce updates the order number and status internally. The order number is used as a foreign key for subsequent updates to the remote system. So really, this pattern is used for small volume real-time activities where you're calling out to a remote system. And in this case, we're using MuleSoft's API kit router as the means for connecting to that remote system. Here are some request and reply considerations when you're trying to implement this pattern. To secure this pattern with MuleSoft, you can either use the two-way SSL or any of the other MuleSoft API security policies. In this instance, for exception handling, ideally Salesforce would manage the exception because the call is typically made in real time, so the user or Salesforce system will know best how to handle that specific exception. Within MuleSoft, there are a couple options for implementing this pattern. You can use the API kit for REST-based APIs, or you can also use the API kit for SOAP-based APIs. Now, within Salesforce, there are many options for implementing this pattern, but the best are to use REST API callouts through enhanced external services, or use Salesforce Lightning or Classic to initiate a synchronous SOAP or REST callout. You can use Apex triggers or a batch job to trigger these, but that's really suboptimal solution for these patterns. Apex triggers can only process asynchronously, so that's not really ideal. And then batch jobs themselves have limit to the number of callouts that they can make. So again, that's not ideal for this scenario. The next integration pattern is called fire and forget. In this pattern, let's use the same example where you use Salesforce to track leads, manage your pipeline, create opportunities, and capture order details that convert leads to customers. However, Salesforce isn't the system that holds or processes orders. After the order details are captured in Salesforce, an order must be created in the remote system, which manages the order through to its conclusion. When you implement this pattern, Salesforce creates a platform event to create the order, but doesn't wait for the call's successful completion. In this instance, MuleSoft uses the Salesforce connector to subscribe to the platform event bus and receives the order to continue processing. MuleSoft can optionally update Salesforce with a new order number and status in a separate transaction once the transaction's made it through its whole process. Next, let's look at some considerations for this pattern. To secure this pattern with MuleSoft, you can either use two-way SSL if Salesforce is making an inbound call. If you're using the Salesforce connector, you can use basic authentication or various OAuth options, including OAuth JWT, SAML, username and password, or OAuth 2.0. For exception handling, it's best for MuleSoft to handle any exceptions because this process is asynchronous, and really it's the responsibility of the middleware at that point. Now, to use platform events with MuleSoft, you use the Salesforce connector. However, you can also accept inbound calls if Salesforce is sending those calls via the API kit or the API kit for SOAP. For Salesforce, there are multiple solutions for implementing this pattern. But the best is process-driven platform events because no customization is required to implement platform events in Salesforce. Outbound messaging is also a good option because of no customization and can also include callbacks that create a unique session ID that can be used by the system performing the callback to authenticate back to Salesforce. So in this instance, if MuleSoft was using that callback, it would have that session ID and then could use that in the return call back to Salesforce to update that order. Apex callouts are suboptimal for this pattern because they require customization and they must handle delivery of the message in the code. This would be similar to the pattern of request to reply, but the difference is that Salesforce really doesn't wait for the request to complete before handing off the control back to the user. So if you think about request to reply, a user is updating, clicking a button, they get a spinny wheel that tells them to wait. In this instance, it's saying that that wouldn't happen, and whatever the user needed to do next would continue on. Finally, the reason for triggers and batch jobs being suboptimal is that they're really the same as the request and reply. Triggers aren't really optimal for this situation, and then batch jobs themselves, again, have limits to how many callouts they can have. So not ideal for this situation. Best is to use platform events. For the batch data synchronization pattern, let's say you need to extract customer activity information from Salesforce and import it into an on-premise data warehouse. When you implement this pattern, the best practice is to use Salesforce Change Data Capture, which publishes change events that you can see in the diagram. With Change Data Capture, you receive near real-time changes of Salesforce records and synchronize corresponding records into an external data store. For MuleSoft, you use the Salesforce connector to listen for these changes the same way that you would for platform events. To secure this pattern with MuleSoft and using the Salesforce connector, you can use basic authentication or various OAuth options. For exception handling, it's best for MuleSoft to handle any exceptions because this process is asynchronous. Additionally, change data capture events aren't processed with database transactions. So as a result, platform events can't really be rolled back with a transaction. To use change events with MuleSoft, you use the Salesforce connector in the same way that you would platform events. For Salesforce, there are multiple solutions for implementing this pattern, but the best is change data capture because it takes care of the continuous synchronization part of the replication process. It publishes the deltas of Salesforce data for new and changed records. However, you could use a third-party tool for replication, including MuleSoft. In this instance, MuleSoft reacts to changes in the source data set, transforms the data, and then calls Salesforce Bulk API to issue DML statements. This can also be implemented using the Salesforce SOAP API. There's also a remote call-in where a remote system calls into Salesforce, but this is suboptimal because this causes considerable traffic between those two systems. This pattern has the potential for, causing continual updates, which could potentially impact the performance for end users of those systems. The last integration pattern that we're going to look at is called remote call-in. In this pattern, let's use the example again where you use Salesforce to track leads, manage your pipeline, create opportunities, and capture order details that convert leads to customers. But Salesforce isn't the system that contains or processes these orders. Orders are managed by an external remote system, and that remote system needs to update the order status in Salesforce as the order passes through its processing stages. As you can see in the diagram, MuleSoft can call Salesforce via the remote system using the Salesforce connector and using the SOAP API to interact with the object directly in Salesforce. To secure this pattern with MuleSoft and using the Salesforce connector, you can use basic authentication or various OAuth options. For exception handling, it's best that MuleSoft handles any exceptions because Salesforce in this instance isn't the system of record that's processing the orders. MuleSoft has multiple types of Salesforce connectors, including the Salesforce connector, the Salesforce composite connector, and even connectors to specific clouds like Salesforce Marketing Connector. You could also use the HTTP connector, but that would require customization. So ideally, you would use any of the Salesforce connectors as long as they meet your needs for your integration. For Salesforce, there are multiple solutions for implementing this pattern, but the best is to use the SOAP and REST APIs that are exposed. Additionally, you can use the bulk API for any bulk operations, and all of those operations are included in the standard MuleSoft Salesforce connector. You could also expose web service methods through Apex class methods, but that would require custom code. Likewise, you could expose REST resources within an Apex class, but again, that's suboptimal for the same reasons that you would have to write custom code. So it's best, if you can, to always use the out-of-the-box SOAP and REST or bulk APIs for Salesforce. Thank you very much for watching this Friends of Max video. I hope you enjoyed it, and I hope you learned something about Salesforce integration patterns utilizing MuleSoft. In the next video, we're going to expand upon that and talk about some of the more of the complex integration patterns and components that you can use in MuleSoft to connect with Salesforce. Again, thank you. I hope you enjoyed this video and looking forward to seeing you on the next one. Thanks.